Welcome to Lesson 8, where we will be combining bases together. Specifically, we'll be multiplying expressions that have different bases. And to be successful in this video, you will be able to use and explain a rule for multiplying terms that have different bases but the same exponent. As we start off with the warm-up, you are given two different expressions. Take a moment to pause the video here, evaluate those expressions, and we'll talk about what we find in a moment. Okay, so let's look at the connections we see between these two expressions. If we were to evaluate this first one, here's what it would be written out, but that would equal 1,000. And the second one is also equal to 1,000 because of that 10 times 10 times 10. So they both equal the same thing. But is there a way to tell just by looking at the expressions without having to evaluate that they would be equal to each other? And the answer to this is yes. Since there are 3 factors that are 5 and 3 factors that are 2, you can group those 2's and 5's together to get 3 factors that are 10. As we move into the next activity, we'll start off by kind of revisiting this warm-up, and so we'll be able to rearrange this to kind of see what we mean by grouping those 2's and 5's together. Okay, so in this activity, exponent product rule, you start with a table. And the table contains products of expressions with different bases in the same exponent. You're going to complete the table to see how we can rewrite them. You're going to use that expanded column to work out how to combine the factors into a new base. So that first one that's done for us does come from the warm-up. So you can see in the first part of the expanded form was what we wrote in the previous slide. And then we regroup them into the 2 times 5 that you see there 3 times, and 2 times 5 is 10, so that's where you're getting those 3 factors of 10 to rewrite it with the exponent in the exponent column as 10 to the third. So we can say that 5 to the third times 2 to the third is the same as 10 to the third. Okay, so take a moment here to pause the video and go ahead and complete the rest of your table and answer question 2, and we will come back together to discuss what we find. All right, now that you've finished the table, we're going to start with the next one, 3 squared times 7 squared. And so we're going to list out those factors. So 3 times 3 and 7 times 7. We're going to group the 3 and the 7 together twice. And we know that 3 times 7 is 21. So we can write this as 21 squared because there are, it's written out 21 times 21. Okay, in the next one, in a similar fashion, we're going to write those factors out and then regroup them to 2 times 3 4 times. And since we know 2 times 3 is 6, and that's happening 4 times, we will write that as 6 to the 4th. In the next one, we start with the exponent column, 15 to the 3rd. So we might already be thinking about 3 times 5 gives us 15, and thinking about how many times do we have to write those factors out and regroup them. So we see here, it's very similar to what's been given in the previous ones. And we would write that as 3 to the 3rd times 5 to the 3rd. This next one has a couple of different answers that you could have went with. So I used 5 and 6 here. So I listed out my factors of 5 and my factors of 6. I grouped the 5's and the 6 together to show that that equals 30. You maybe used 10 and 3, and that's totally acceptable. So as long as the structure is the same. My expression was 5 to the 4th times 6 to the 4th. So if you did have 10 to the 4th times 3 to the 4th, that is acceptable. In the next one, we now have a variable term as one of the bases, but the process is going to remain the same. So you see here we have the 4 factors of 2, the 4 factors of x, group them together as 2 times x 4 times, and we would write that as 2x to the 4th with that parentheses around the 2x to make sure that whoever is looking at this knows that the base is the 2 and the x and not the x by itself. So in this next one, obviously we don't know how many times to list those factors out. So kind of looking at the patterns of what we've been seeing is where we're going to start to develop that rule. So we're going to say that for bases that are different, that have that same exponent, that we can write that as a times b and keep that exponent the same. The last one gives us an expression with 3 different components here. So it's the same process, but this time we have a little bit more to work through. So 4 factors of 7, 4 factors of 2, 4 factors of 5, regrouping each of those into 4 groups that have a 7 times a 2 and a 5, which equals 70. So we would say that this is equivalent to 70 to the power of 4. So what happens if neither the exponents nor the bases are the same? Can you write 2 to the third times 3 to the fourth with a single exponent? If the exponents are not the same, the factors cannot be grouped together evenly. It is not possible in this case to write the expression with a single exponent because regrouping it into factors that are 6 will leave an extra factor of 3. So let's look at this in detail. So we have 3 factors of 2, 4 factors of 3. We can regroup it into 2 times 3, 3 times only, but we still have that 3 left over. And so no, it is not possible in that case. And that kind of proves the why to it. So overall, we can say that the quantity of a times b raised to the power of n is the same as saying a to the power of n times b to the power of n. And so we'll use that as that rule here for our exponent product rule. Just some summary questions. Is it possible to write the following using a single exponent? We have different bases, our exponents are the same. The answer is yes, we can write that as 20 to the power of 5. What about this using a single exponent? Not here. You could combine 3 factors that are 4 and 3 factors that are 5 to make 3 factors that are 20, but there are still going to be 2 factors that are 5 left over. So again, although our bases are different, our exponents are different as well, so we cannot apply that rule here. When is it possible to combine bases together in a single exponent? It's only possible when both bases have the same exponent. You can go ahead and read that lesson summary if you choose to. Otherwise, you were successful at this video if you're able to use and explain a rule for multiplying terms that have different bases but the same exponent.